Hi, this is Dr. Simon Romero, and I'm here to present you a problem. Evan is not here right now, so you will have to hang with me today. And the thing that we're going to do is we're going to talk about a particular problem of the cross product in section 12.3, and it's a problem about finding areas of triangles and vectors perpendicular to the plane containing certain points. These are the two main applications of the cross product, and it's going to give you a good idea of how we're going to use the cross product in the future. So the thing that I'm going to do right now is to invite you, if you have any kind of like problems that you want Evan to work on, hopefully not me, you can post them on the forums, on the My Courses page for the class. And then you can, we will try to do them. Remember that we will not do problems that are part of your homework or, well, sorry, class activities. So make sure that your requests are different problems from the ones that you have to do on your own. But anyway, so I will let you work a little bit on this problem, pause it, take your time, and then when I come back, I will solve the problem. So hi, I'm back. So the idea is the following. We're going to have 3 points, and these 3 points, we are going to try to find the area of the triangle. And if you remember, or this section is about vectors. So the first thing that we're going to do is we're going to create some vectors. Before doing that, so every time that you have 3 points, if they are not aligned in the space, if you have 3 points in the space and if they are not aligned, they create a triangle. Again, this is not, I really don't know, I'm not interested where these points are located exactly. This is not a graph, this is just kind of like an idea of how we are going to proceed. So the first thing that they're asking you is to compute the area of this triangle. The second thing that they are asking you is, well, this triangle is going to be contained in a plane in the 3-dimensional space. So suppose that this is the plane where this triangle is contained, and the thing that they're asking you is to find something that is orthogonal, a vector that has unit 1, a vector that has unit 1 and is orthogonal to the plane or perpendicular to the plane. So this is our objective, to find those two particular pieces of information. The first one is the area. So in order to compute this area over here, the thing that we're going to do is we're going to try to transform everything into vectors. So the first thing is we're going to create the vector PQ and the vector PR. It really doesn't matter which 2 vectors you take. I'm just going to take these ones, and we're going to put the numbers in just a moment. Once you have these 2 vectors, you can compute the cross product. And if you take the magnitude of the cross product, it's going to give you the area of the parallelogram formed by these 2 vectors. This triangle is just half of the area of the parallelogram, so at the end, the area of this triangle is just going to be a half of the magnitude of PQ cross PR. So that's our first objective. So that will give you the area. And then once we are done with this problem, the part A, in part B, we are going to try to find the unit vector perpendicular to the plane containing PQ and R. So let me go to the other side and let me start working on the first part of the problem. So the first challenge is, right now we don't have vectors, we have only points. So let me just put the points again right here, and I'm going to start creating vectors. So let me just put P is equal to 2, negative 2, 0. Q is equal to 0, 1, and negative 1. And the last one is r is equal to -1, 2, -2. So if you see in our drawing over here, we're drawing the vector from P to Q. So in order to get the components of this vector, we have to subtract each one of the coordinates of Q with the corresponding coordinate of P. So we're going to do that. So the vector PQ is going to be given by these components. I'm going to use brackets. You can use ij's and k's if you want to. I just find, for me, it's easier to just use the bracket. So I'm going to do 0, -2. So I'm going to go tip minus tail of in each one of the components, tip minus tail. And the last one is tip minus the tail. Let me just simplify this. And that will give you -2. This gives you 3. And the last one gives you -1. So this is the vector PQ. Now I'm going to do the vector PR. Now notice that P is still the tail of this vector, so I can keep kind of like the second part of this computation. And I am going to replace the coordinates of Q for the coordinates of R. So you have -1, 2, and -2. So finally, we get from here that this is -3, 4, because just you have 2 minus -2, so it's 2 plus 2, that is 4. And the last one is -2. Okay, so finally we have our two vectors. So the thing that we're going to do is we're going to compute the cross product between them and then take the magnitude in order to get what we want. So let me start computing the cross product between these two. Once you get kind of like confident with the cross product, you will not need to do this step. So this is the determinant, and remember this is a good way to recall how to compute this cross product. We put the components of the first vector here and the components of the second vector here. All right, so now we have these, and I'm going to just start putting my multiplications over here. One of the things that you have to remember too is the second component is going to have a minus on this side. So let me start. I'm going to do 3 times -2. So I'm going to put it here. 3 times -2 minus -1 times 4. -1 times 4. We'll put the comma here and the negative here. Oh, I may need more space. Probably I will need some more space, so I'm going to just put my more space over here. So the next one is negative, so this negative is in the second component, and now we're going to do -2 times -2 and minus -3 times, or -1 times -3. This is the same, but I want just to follow the same order that I have been doing. So that's for the second one, and the third one is just going to be, third component is going to be -2 times 4 minus 3 times -3. I told you have to be very careful when computing these cross products, because you have a lot of signs that you can get really confused onto. So here you have 3 times -2 is -6. You have -1 is +1, so you have +4. So the next one has a minus, so let me just keep the minus here. I'm going to try to be very careful with this sign. So you have -2 times -2 is +4. Minus with this minus is plus, so you have plus here, +1 times negative 3 is negative 3. So that's the second component. And the third component is going to be negative 2 times 4 is negative 8, minus, with this minus is a plus, plus 9. So at the end, what we have, let me just erase, we don't need the determinant anymore. It's going to be negative 6 plus 4 is negative 2. Negative 1 is what we have in this one, and this one gives you 1. Let me verify really quickly if we actually have the right cross product. So negative 2 times negative 2 is 4, positive 4, minus 3, minus 1, so that you have positive 4, minus 4 gives you 0. So far so good. 6 plus 4, minus 4, minus 2. So 6 minus 4 minus 2, it gives you equal to 0. That means that our cross product computation is accurate. So now that we have the cross product, we're going to try to use the cross product to find the two things that we need. So the first one is finding the area of the triangle. And in order to do that, we need the area will be equal to 1/2 the magnitude of the cross product. So let's just compute that one. So you have 1/2 times the square root of, and remember that taking the magnitude of a vector is just squaring each one of the components. So you have negative 2 to the square plus negative 1 to the square plus 1 to the square. So what we end up with, 1/2 times the square root of 4 plus 1 plus 1. So that gives you 1/2 the square root of 6. And you can leave it like that, or you can just say, well, the square root of 6 is square root of 3 times square root of 2, and that's equal to square root of 3 over 2, square root of 2. So that will be our result for the area of the triangle. So once we have the area of the triangle, I'm going to just focus on what happens in here. So our second problem is to try to find what is a unit vector in the perpendicular to the plane. So one of the things that we know is that P cross R is a vector that is perpendicular to both, or orthogonal to both P and Q. So the thing that we're saying is that the vector PQ cross PR is a vector that is perpendicular to both PQ and PR. So the only thing that we need is we just have to make it a unit vector. That means that we have to take the vector PQ cross PR and just divide it by its magnitude. So we're going to do that. So let me just erase this part over here, and you will see that we have all the ingredients already. So let me just, I think that I have this little space where I can just finish the problem here. So we have PQ cross PR. Just going to copy what we have in the other, in that side. So we have PQ cross PR is -2, -1, 1. And the other thing that we said is that the magnitude of PQ cross PR, not very difficult to see that this is actually equal to the square root of 6. So the thing that we have to do is the unit vector that we're looking for. By the way, this is just the solution for part B of our problem. The unit vector is going to be 1 over the magnitude, square root of 6, times the vector minus 2, comma, minus 1, comma 1. And that's equal to, let me just bring it in. So this is going to be negative 2 over the square root of 6, comma, negative 1 over the square root of 6, comma, 1 over square root of 6. I could simplify it more, but I don't want to bore you with the algebra that actually I did over there. So I will just leave it like that. And that will be the result for the unit vector perpendicular to the plane containing PQ and PR. Just remember that you can have this vector or minus this vector will also be a solution, because you can alter the order between PQ and PR, and you will get negative this vector, and negative this vector will give you negative this vector once you get the unit vector. So with that, I finished this particular problem. I hope that this is the last time that you see me in these practice exercises. I'm trying to convince Evan to do more. But anyways, that's all for today. And please, in the forums, ask us what problems do you want us to work on. Thank you very much, and have a very nice day.